Hi students, this is Dr. Thomas here, and I wanted to address some of the problems that you were having from chapter 4. And so I have 3 problems here. Let's start with solving for S when we have P equals L plus S over F times I. So S, since we are solving for S, what does that mean exactly in math? Solving for something means that we're trying to isolate S. So if we're trying to isolate S, we're trying to get this on one side by itself. So that would mean that we want to get rid of everything else from the side that S is on. S is on the right side of the equation. So we can get rid of the L first, because this is a plus sign and it's addition. And how do you get rid of something? You do the inverse. So since it's a positive L, we subtract L from both sides to get rid of it. L minus L cancels out. That's why we'll have P minus L on the left side. And on the right side, we have S over F times I. Now next, we have to get rid of F somehow and I somehow. There are a couple ways you could do that. But first, you could get rid of the F. Now, if this is S divided by F, what is the inverse of division? It's multiplication. So to get rid of the F, really you need to multiply by, so you can multiply by F over 1 or just simply F. Since this is considered to be F over 1, then we know that F is in the numerator, right? And if I multiply F on the right side, I need to multiply F on the left side. Now, I'm not just multiplying F times P, I'm multiplying F times the whole left side. So I would have to put a parenthesis around all of the left side to indicate that I'm multiplying F by the entire left side. Now, on the right side, what's nice is I'm at least getting rid of F. Now we have F times P minus L. Now on the right side, we still have our S, but we have that I attached to it. Now when you have something right next to a variable, right next to another variable, or a number right next to a variable, all of that is understood as multiplication. So this is S times I, or in other words, S dot I. So how do I get rid of the I? Again, you will have to do the inverse of multiplication, which is division. So we will divide by I. That gets rid of the I's, and voila, we have S on one side by itself. So F times P minus L, in parentheses of course, divided by I. That's how you solve for S in this situation. So I guess the moral of that story, you always performing the inverse of whatever operation is going on at that time to isolate a variable. So I saw a problem, A plus B squared minus A minus B squared divided by 2AB. And of course, I'm thinking the instructions are to simplify, and that is a good point to read instructions, to be familiar with what the instructions are asking you to do. If it says simplify, obviously that means to make simple, right? So we have this complicated polynomial divided by this monomial, well, to simplify, we have to expand the a plus b squared. Now, what a lot of people don't realize is that a plus b squared means a plus b times another a plus b. There is no shortcut way to get that. So I see a lot of students just go a squared plus b squared. That is not true. A plus b squared equals a plus b times a plus b, and that does not equal a squared plus b squared. Also, on the other binomial square, a minus b squared, that means a minus b times another a minus b. So what we're going to do is FOIL that out, first, outer, inner, last. And if you're not familiar with the term FOIL or the acronym FOIL, it really just means to multiply. Okay, so let's not get caught up in what FOIL means. It just means to multiply everything in one parenthesis times the other. And we use the term FOIL when we are multiplying two binomials together. So first, a times a squared, outer, a times b. That's a positive ab. Then we also have another ab. Please write your variables. For the most part, we want to write them in order. This just helps because we could have written BA, but isn't it just best to write everything in order? Then you can identify your like terms more easily. And then we have b times b, which is b squared. Now, the trick is putting a minus sign next and put up a large parenthesis like that and not worrying about changing signs until after you multiply a minus b times a minus b. So a times a is a squared, a times negative b is negative ab, then you have another negative ab, and then you have plus b squared. So we have a squared. Now these are like terms, so that's 2ab plus b squared minus, all right, and again we have negative 2ab plus b squared, all divided by 2ab. So a squared plus 2ab plus b squared. Now it's time to go ahead and change our signs. So that's minus a squared plus 2ab minus b squared. So notice all of the signs changed to the opposite because there was a negative on the outside or a minus on the outside of that parenthesis. Now you can see that we can cancel out the a squareds. Also, the b squareds can cancel out. So we have 2ab plus another 2ab. Those are like terms. 4ab over 2ab. And I like that the a's cancel, the b's cancel, and you're left with 4 divided by 2, which we know is 2. So definitely, that is definitely simplified from all of this all the way down to just 2. Next, we have a situation right here where we are dividing 9x plus 6y divided by 3xy. So whenever you're asked to divide or simplify here, then if you are dividing by a monomial, and a monomial meaning one term, if you're divided by one term, here is the process. You are dividing each term in the numerator. Each term up here needs to be divided by 3xy. You can't divide 9x by 3xy and not also divide 6y by 3xy. So that's really the main issue I see with students. They want to cancel things out on one side of this problem. They want to just do this. But if you look at it, think about it. Everything in in the numerator is being divided by 3xy. So you should first at least write down 9x divided by 3xy plus what else is being divided by 3xy? 6y is also being divided by 3xy. And what you can do here is cancel these out individually. So we have 3 goes into 9 3 times. The x's cancel. And what's left is 3. Go over here. For the first part, right? You had a 3 in the numerator. And you left with a y in the denominator. Plus, now on this side, you have 3 goes into 6 2 times. The y's cancel out in this case, but we have an x in the denominator. So we have 2 in the numerator divided by x. So here you go. 3 over y plus 2 over x. There's nothing else you can do. I mean, you could try to bring this back together. I don't think it's necessary. This is good. This is one answer, but this answer is also equivalent to, if I rewrote this answer, let's say if I wanted to put this together as 1, then our LCD would be xy. So you'll multiply top and bottom on this side by an x and this side by an y, so that you have the same denominator, xy. And then what you have is 3x plus 2y over xy. Now this answer here is actually equivalent to this answer. But if this is the simplest way to do it here, this is one step further here. So I'll take either answer in this case. All right, this concludes the video on challenging problems addressed. And if you have any more questions, please post it in the discussion board, the problem solving discussion board, so that your classmates can help you out a little bit before